Hey, I wanted to record another video and show you as well um, the demo on the project from scratch as well, just in case if you had more questions about it. Since I wasn't able to complete all the details on the project within the 15 minutes of the video, I was able to show the requirements that have been met, all the requirements that have been met, of course, on the project, but I wasn't able to show how exactly the demo of the project works. So I'm recording this additional video to show you. First of all, I've removed all the generated results. Data folder is empty, and certain CSV files and the plots and the other files are the results are deleted as well. So I'm gonna be like starting from scratch. First of all, this is my data generation.python file that basically generates the random, I guess, the CSV that for testing out. And in order to run that, we use the first. Over here, I've been getting some Python warnings, and that's why I put on the ignore mode. And gonna be just running this. And as you can see, we got the factory sensor.csv file within pretty large file, over the 2000 lines. And as you can see, there's a temperature, pressure, psi, and power, and label and humidity. Label is usually 0 or 1. And yeah, and this is for our CSV file. And then we're gonna run the runner.python file. Basically, what this code is been doing is it's importing all these criterias from the source profile, load the profiles over here. It puts on the evaluation, apply latency failure rows, and a bunch of different other stuff here that it will be a very long video if I want to show every single details on the code, but I hope you can have access to it from my GitHub link. It's a pretty long file that does a lot of stuff. And then yeah, and then I'll be running this code. This basically should do our task. And as you can see over here, wow, we got the CSV file on that. We got the audit.log just in case there's any error. MD little file as well, basically giving me some details, small details on what's the issue exactly on the file, on the testing as well, if there will be any. And the JSON file over here, and another MD file over here with more details. And we get the operation envelope, the CSV, and the product demo, the result, which is one of the most important for, which actually puts them in the different models. Is an MLP or logistic regression, and it has different types of constraints and clean accuracy and effective accuracy, as you can see on the delta as well over here. And then if we move on to the next command, it's just to show whether the files has been made already, which are these are all the files that have been made today, which there's a lots of them over here, and as I mentioned before over here. And then we move on to run this as well. This is just to show you in the terminal that some of the constraints we have and everything over here. And as you can see, we have a different types of model and different type of constraints on the profile, and the accuracy and a bunch of different details on this as well. And for this one, would be showing the profile, the constraints on latency. Here we go. The first one was on the noise, and this is on the latency that it shows. And then now we're going to generate the dashboard for this with this the command, and as you can see, master dashboard.png is made from this file, just generated right now. And this is the dashboard generates running this command. And then for the next, which I don't really need to open it, I just opened it. And now I'm just gonna show you the week 6 of report.md file as well. Yeah, and this is the MD file, that the markdown file, as you can see over here, that's been generated over here. This is the markdown file, actual file here. And then for the next one, we're going to be moving on. Then we're going to generate the PDF report, and as well reviewing it. We're going to get a PDF report on this. And this is the PDF report. It shows the dashboard, it put the audits, the markdown file over here, and regression over here, and it just gives you some recommendation on what to do if there's any kind of issue. Alright, now we're moving on the NASA, which basically I installed the adapter. Over here I put the NASA adapter, the Python file over here. What it does, it goes directly through the website in the NASA link and downloads the zip code and gets the CSV file, and gets that CSV file and then puts in our data, and it uses actual data instead of generated data, which I think it's a lot more accurate. So now we're gonna run this adapter, and as you can see, it says downloading NASA file over here. Here we go, nasa.csv, and this is the zip. This is the CSV file that's been downloaded from the NASA website directly. And now we're gonna be running this as well, this full code as well. To run some details on the code for us as well. It audited our CSV code on it. Then I'll show you some details on the audit. We're gonna see some high risks, if I'm not mistaken, over here on the after training the model and predicting on the new data's on it. Over here, staleness on the logistic regression model had a pretty high risk, and then after that was latency on the logistic regression, and then MLP. Overall, as you can see on the logistic regression model, on a staleness and then latency have the biggest loss and can be highest risk on this. And then over here, we're gonna generate the dashboard for it. And this is the dashboard. This is the new master dashboard for the NASA model over here, for the NASA data, as you can see over here. And then on the last code, just gonna show you some markdown file on our NASA code and PDF report, so we can see more result on this as well. And it just opens up the executive report, which would go to the executive I guess team after they run this audit, and it shows the results and CSV files and some recommendation latency to major failure mode, which we saw it actually. And staleness, herding reliability, consider freshness check, timestamp validation, or JFigure. And these are all also based on the PyTorch model. Just to show you a load of small details that I might have forgotten to show you, on my source, this is my main file, the runner.python file. This is the main one. That's a pretty long file over here and does a lot of stuff over here. Reliability regression. There's one. Oh yes, this is for the PyTorch model. And there's also plot result. This basically make the plot from the result from the CSV file. This makes the report. And again, all these are built in each Python, but on this main file, all of them loads the result. It loads in this file. That's why I need to only run like one command. Like if I show you here, as you can see, anytime I run the Vix6 runner, it does every task that I needed. So I don't really need to do a bunch of different things in it because all of them are loaded in this. The results are loaded in the Vix6 runner.python file, and that's why throughout one I can just go to that. This one builds the data, the builder dashboard. This one works on the constraints, and this is the adapter. So later on, if I wanted to files from different websites or different type of CSV files, I can just make another Python file on the adapter folder and add them over here and edit on my Vix6.runner and have different data. And we get all the results like that very easily. And there's also another run product.python if I want it, but it's already loaded in this particular file as well. And this is the main readme.md about the project, and usually this CI needs to be changed to burning or green depending if the project is going well, if the risk is high or not high enough. Thank you so much for attention to this matter as well, and hope I was able to show the perfect demo on the project without having any kind of issue on this. Thank you so much.